and we are going to do some of the sample problems from problem set 10.3 in Pearson Chemistry. Pearson Chemistry is a book that looks like this. If you own this book, if you can turn to page 326, you can follow along. If not, then take a look at the pictures that will be in Canvas later, and you can see many of those problems, okay? So where'd my glasses go? Not there on my head, but those are my antlers. Let's go. Oh, wow, those are reading glasses. Okay, let's go to page 326, and I'm gonna switch screen share and go to the document camera so we can take advantage of that technology. Here we go. 326. Uh-oh, wait a second. They're not plugged in. It is not plugged in. So now I have to plug it into my USB, and we'll try that again. Stop the screen share, and we'll go to the camera. There we go. All right, we are trying to do page 326. Let's do the sample problem real quick and then see if we need to do the problem itself. What was the assignment? The assignment is it's a problem set. Let's focus a little bit better. No, this camera's been goofy lately. Let's do that. Is that better? It's a little better. Okay, this is problem set 10.3, chapter 10, section 3. That is pages 326, and it goes all the way to 333. I don't remember exactly which problems you need to do. So let's get out of screen share and go back and look at Canvas. Let's see, it is 326, 33 to 42. Those are the numbers of the problems. So we're going to do some of the samples and then some of the problems as well. So let's go ahead and get started. And we'll start by switching back to the document camera. Hope you have a good week. Today's dress up day was dress up like a Christmas character. That's why I have Buddy the Elf on there. Buddy the Elf, what's your favorite color? Mine's blue. Okay, so problem set 10.3, 326, 333. Let's go to 326 and let's look at the sample problem together, and then maybe we'll do another problem and see what to do on that one. All right, here's the problem. Let's see, need more light. And it says, calculating percent composition from mass data. When a 13.60 4 sig fig sample of a compound containing only magnesium and oxygen is decomposed 5.4 grams, 5.40. So that 0 is significant. So it's 3 sig fig and 4 sig fig here. 5.4 grams of oxygen is obtained. What's the percent composition of this compound? All right, so we're going to do that by mass. And what we have is, we know what the total mass is. The total mass is 13.6. And then if the total mass is 13.6, then we can figure out what the mass of the percentage of the mass of oxygen is, because we know the mass of oxygen. So that's going to be 5.40 divided by 13.6. So in other words, the mass of the oxygen divided by mass of the total. And that's how we're going to get that. So, so that's what happens down here, actually. It says percent oxygen. Percent oxygen is mass of the oxygen divided by mass of the compound. They give it to us though, right? They give us 5.40 divided by 13.60. So that's why you get this right here. And to make a percentage, then because this will be in decimal form. That is the alarm to go to chemistry at 3:30. So over here you have 5.4 divide by 13.6, multiply times 100 and make it a percent. Okay, so the two together make up 100%. So you could do it this way. You could say 100 minus 39.7. And so you can do that in your head. 100 minus 39.7, which is about 40. So it's going to be about 60. So 60 what? 60.3. There it is. So you can do it in your head. But if you don't want to do it in your head, here's the mass of the magnesium. And how do we get the mass of magnesium? Well, it says here it has only magnesium and oxygen. So we know that the total is 13.6, the oxygen is 5.4, then whatever's left has to be magnesium. So 13.6 minus 5.4, whatever that is, 13.6 minus 5.4 is 8.2, 8.20, three significant figures. So we're going to take 8.2 and divide that by 13.6, and then we must be somewhere, there it is. 8.2 divided by 13.6 with three significant figures, multiply times 100 and make it a percent. And same thing, you get 60.3, which is the same answer we got when we just subtracted it out. Woo! Okay, so now you know how to do the sample problem. Let's do number 33 itself. So here's number 33 down here, and it says this: a compound is formed. I don't know why it's not focusing. There it goes. A compound is formed with 9.03 grams of magnesium combined completely with 3.48 grams of nitrogen. What's the percent composition of this compound? Okay, let's do it. So on my paper, let's write down what we know. All right, from number 33, it said the compound is formed when you have, my glasses, where'd they go? Lost them last week too. I bought some more at Dollar Tree, which by the way is now $1.25 tree. Did you notice? What kind of name is that? $1.25 tree. Yeah. Okay, so stupid pandemic. 9.03 grams of magnesium. 9.03 grams magnesium. And you got 3.48 grams of nitrogen. What's the percent composition of this compound? Well, look, you got 9.03 and 3.48. Add that together. 8 plus 3 is 11. Carry the 1, 5. 9 plus 3 is 12. 12.51 grams of that compound. Let me tell you what the compound is, right? Oh, how to focus. So now we have the total. Now you just gotta go 9.03 divided by 12.51. These are in grams. And then you're gonna get this. You're gonna multiply that times 100, which is the same as moving the decimal over twice. And so let's go to the calculadora. That's calculator in Espanol. I still get that error message. Oh gosh darn that error message. All right, 9.03 divided by 12.51 equals 0.7218. So when you multiply this times 100, 100 has 2 zeros, same as moving this over too. So it's going to be 72, 3 sig fig, 4 sig fig, 3 sig fig is what we want, 72.2. Okay, so this is going to be 72.2%. And then for the other one, same format, 3.48 divided by 12.51. Let's do that. Clear. 3.48 divided by 12.51 equals 0.2781. So that's going to be moving it over twice. 1, 2, 27.8%. Add them up, it's 100. And the shortcut the other way that we did on the sample problem over here, 100 minus 72 is that. So if you didn't want to do this part, you Could have done 100 minus 72.2. We'll give you 27.8. What is this one? This was magnesium. And then this is nitrogen. So box your answer. Show your work. Ta-da, number 33. Cha-ching. Check that off. All right, you should be able to do number 34. See, the thing is, I give you a sample, and I just did one of the two. Now I only have another one left. So let's look at the samples, and maybe if it's not clear, then we'll do one of the other ones. So I'm not going to do 34 with you. Give you a chance to do that one on your own. Let's go to the next problems, the next sample, the next problems. Here we go. So here are the problems. Calculating percent composition from a formula. Here's the problem. Propane, the fuel commonly used in gas grills, is one of the compounds obtained from petroleum. Calculate the percent composition of propane. Well, what's a formula for propane? Well, the formula for propane is C3H8. How do I know that? Because they gave it to us in the problem, C3H8. So now I know I have 3 atoms of carbon and 8 atoms of hydrogen in 1 molecule of propane. Alrighty. Calculate the percent composition of propane. So we know we're going to have carbon and, well, here, I'll just write it over here. I've got C3H8 is the formula for, oh, that's 34. Remember, I was going to leave that blank and give you, oh, this is the sample problem. Let's go, give you this space, and then I'll say sample 10.10 is what that is. That's on page 327. Okay, so let's do it though. All right, so now we have propane, which is C3H8. We're trying to figure out what the percent composition is of propane, but we only have 2 chemicals, carbon and hydrogen. So there's carbon and there's hydrogen. All right, so over here we were given some grams, some masses. But here what we're going to do, the trick is use the molar mass. Now the molar mass is, you can probably do this one in your head, because you know that carbon has an atomic weight of 12.011. Let's just call it 12. And the hydrogen is 1.01. Let's just call it 1. So this is 3 carbons, so 3 times 12, 12, 24, 36, 36 plus 8, because there's each of these weighs 1, 36, 46, 44. So the mass of, the molar mass of a propane is 44 grams. What? How did he do that? Let's just do it over again. Okay, so I got 3 atoms, and the 3 atoms weigh 12.011. And then I have 8 hydrogens, and they weigh 1.01. Okay, so I'm going to punch it in the calculator so you can see it. 12.011. This is from the periodic table of elements. Times 3 equals 36.033. Probably could have done that one in your head. This one's 8.08. Probably can do that in your head, but let's look and make sure 8 times 1.01 equals 8.08. Add those up. You get 36.033. Total is 44.113. Let's see. So I was going with just 44. So my answer would have been in 2 significant figures. Here's 3 sig fig. I can bring it to 44.1 grams per mole if I really need to. All right, I think 44 is just going to be fine. Okay, if that's the case, then if we have 36 grams of C, and now we have 8.8 grams of H. Remember, you got to round off at the end. So to figure out the percent of carbon, what you're going to do is take the carbon's weight, 36.033, and divide that by 44.113. And so this is grams and this is grams. So you get a dimensionless number, but we're going to express it as a percentage. So we have 36.033 times 44.113 equals, whoops, must have done some goofy, 36 times, because that can't be the answer. Oh, 36.033 divided by 44. Just slow down, I guess. Okay, that makes more sense. Move the decimal over twice to make it a percentage. That makes it 81.7. That's to 3 sig fig. That's 3 sig. That's 3 sig fig. That's 5 sig fig. We're going to express it as 3, I guess, for now. 81.7 is percent carbon. Well, that's 81.7. 100 minus 81.7 is going to be close to 20. 19 to 18.3. Let's make sure. You could do it 2 ways. You could say 100 minus 81.7 equals 18.3. Or you could take this number here, 8.08, divide that by the total, which is 44.113. 44.113 equals, same thing, 18.3. Ta-da! Box your answer, show your work. That's a sample. Let's do the other one. Let's do 35A. 35 has 2 parts, A and B. Let's go to A. 35A, what's 35A say? Calculate the percent of mass of nitrogen in these fertilizers. All right. You have NH3, and we want to know what the percent nitrogen is. Well, in NH3, the molar mass of NH3 is going to be 14 plus 3, it's 17. How do you do that? N periodic table, 14. H is 1. You have 3 of them. 14, 15, 16, 17, 17 grams. Again, nitrogen weighs, and that's the mass of NH3. The mass of N is 14 from the periodic table. So the answer is going to be, for percent nitrogen, it's going to be 14 grams divided by 17 grams. What's 14 divided by 7? Hey, Siri. Oh, I don't have my Bluetooth on. Okay, so 14 divided by 17, because the Bluetooth attaches to my speaker. So when I'm lecturing, I turned it off. I have 0.048. I want to go 2 sig fig. So we'll bring it over there. So then my answer then is 4.8% nitrogen. That's for 35A. Okay, 4.8% nitrogen and 48. No, that can't be right. That's not right at all. Because 14 out of 17, 14 is almost 17. Calculator must have goofed. Let's do it again. 14 divided by 17 equals, oh, where'd that number come from? Because this is 82.35, which is 82, well, just 82. So 82%. 2 sig fig, 222, 82%. What is this? Nitrogen. Ooh, good thing I caught myself there. That's 35A. 35A is 82%.
Excuse me?
Yeah, sure. What's up, Lutz?
Wouldn't it be 82.4?
82.4. Well, that's if I went to 3. Oh, gosh. If I went to 3 sig fig, it'd be 82.4. But I used the numbers from my head, which is at 2 significant figures. Like this is 14.0, I think. And then this is, I didn't, well, let's look. If I had used better numbers and I wanted to get to 3 significant figures, that's when it would be 82.4. Okay, so I think that this is actually 14.0, which make this, when I add 3.03 to 14, that's going to be 0.03, which makes this 17 is, the total weight of ammonia is going to be 17.0. So if you're taking it to 3 sig fig, it is going to be 80. I'm pointing, but you can't see. If I take it to 3, it's going to be 82.4 for sure. You're right. But I only took it to 2 sig fig because
So if I got 82.4, is that fine, or do I have to change it to 82?
Oh, well, it just depends. Like for me, if you looked it up in the periodic table, let's look it up in the periodic table. And so I'm going to go over here on page 100 or something, because I'm getting close, and is 14.007. Okay, so that's 5 sig fig, and over here is hydrogen. 1.008 is 4 sig fig, but that actually tells you 1.0049 or 79, not 49. So if I had used these numbers directly from the periodic table, I could have got my answer to 5 significant figures. You know, remember, it's your answer should be in the same number of significant figures as your as the lowest number out of the items that you're using to calculate. So for me, I knew it was 14, so that's why I was calling this 2 significant figures. When you look it up, it's 14.007. So again, that could have been 5. But if I kept it exactly like I have it here, this is 3 sig fig. This also is 3 sig fig. So if that were the case, then the answer would be sure 82.4. But for me, 82% is good enough, since I was going with 14 grams and 17 grams instead of 14.0 and 17.0. Again, you could have used 5 sig fig and then gone 14.007 and 17.010, and then you would have had to take this all the way to 5 sig fig. From a mathematical point of view, practically speaking, you would need a really, really, really good piece of equipment in order to get to that degree of accuracy. So I'm calling it 82. 82.4 is also an acceptable answer. Woo!
Thank you.
Good question, Lois. You're welcome. All right, let's go on. Let's go turn the page, go to 10.11. Look at that sample real quick. I don't know if we have to write it down, but let's look at it. What we're going to do is you're going to calculate the mass of an element in a compound using percent composition. Calculating the mass of an element in a compound using percent composition. So if you know the percent composition, you can figure out the mass if you know the total mass. So let's look. It says calculate the mass of carbon and calculate the mass of hydrogen in 82% grams of, or 82.0 grams of propane. Okay, so for that one, you want to figure out how much carbon in grams there are and how much hydrogen in grams there are in 82 grams of propane. Okay, so what we want to do is, in this case, let's see, we're going to say, we can use what we did before, because we actually in sample 10.10, where is that? In sample 10.10, we already figured out the percentage. And this is of propane. There's propane. Propane is 81.7% carbon and 18.3% hydrogen. So the question is, how much mass is that then? Well, if you have 82 grams, well, then you're going to take 82 grams and multiply that by, where'd it go? 81.7. So let's do that. 82 grams times 81.7%. So to do that on a calculator, I'm going to move it back out of percentage and do it in a decimal form. So times 0.817, because I'm going to move this over 2 to the left in order to convert it back to a decimal form, equals, and my answer is for this one, 69.994. Looks like we have 3 sig fig. So this is going to be 67.0. So my answer for this one is 67.0. Oh, and you can see that. Let's see, where are my glasses? I forgot we were doing the sample problem. There it is right there. 67. All right, so we have 80. Oh, my answer is 81.7. They have 88.8. And then, and so then you got 100. Oh, no, you have 82 grams. So 82 grams, 81% of 82 grams is, whatever I just said, 67.0, or in your book, 67.1. Same thing here. In sample 10.10, you have 18.3, so we're going to move that back over. And we're going to get 0.183. We're going to take 0.183, multiply that 0.183. Then we're going to multiply that times the total mass, which is 82. We'll get 15.006. 3 sig fig makes us 15.0. So that's how we got 15.0 there. Okay. All right. So that's how you do it in the sample problem. You should be able to do these two the same way, but let's do one. Let's do 37A. There's 37A. Let's bring it over here so you can see it. 37A says calculate the grams of nitrogen, 125 grams of each fertilizer. Grams of nitrogen and 125 grams of NH3. So that is the ammonia. So the mass of ammonia is equal to 125 grams. That's a total. We have NH3, and the mass of nitrogen is 14.007 grams per mole. Okay. And so, so what you have here is grams of nitrogen. We're going to take 14.007, divide that by 125. So we got 3 sig fig, because that's what's given right there. Get the calculator out. And here we go, right there. Bring that up so you can see it. Clear that, focus that. 14.007 divided by 14.007 divided by what? 125 equals 0.112, but we're going for a, oh, we're going for grams, aren't we? What is given here? We have 14 grams. calculate the grams of nitrogen and 125 grams of total. Well, these grams are, although it says grams, this is grams of nitrogen, and this is grams of ammonia. So, so then we get a percentage, and the percentage is what we just got. We got 11.2%. Okay, so calculate the grams of nitrogen in 125. What did I just do? 37A. I think I got 125. What else do we have? Are there other numbers that we have? Oh, I see. You know what? That's how much we have. But I forgot to do 14 plus 3, which is what? What's 14 plus 3? And the brain fart, 17 grams. Now the mass, the molar mass of ammonia is 14.007 plus 1.008 times 3, which is 1.08 times 3 is 24. We add that up, we get 130. That's a 3, 17.031. So the mass is 17, but I have 125 grams of it. This is, and 17 grams per mole. And so how many moles do I have? Well, I'm going to have 17.03, 17 grams per mole. I have 125 grams given of NH3, and I know the molar mass is 17 grams of NH3 per mole. So I'm going to know how many moles of this I have. So that's going to be clear 125, 125 divided by 17 equals, I have 7.3529 moles of NH3. And what's the question? Calculate the grams of nitrogen in 7.35 moles of NH3. So I want to end up with grams of nitrogen. Well, now I have 7.3529 moles of NH3. For every mole of NH3, I have 1 mole of N, and 1 mole of N weighs, we just figured out, 17 grams. Righty. So how much do I have? Well, these all cancel out. This is moles of NH3, moles of N, grams of N, which is what my answer to be in. And so if I multiply that out, 7.3529 times 17 equals, equals 125. Well, of course it does, because that's 125 is what was given. All right, so out of the 125, how many nitrogens do you have? Remember, the nitrogen percentage is what we figured out was 14.007 divided by 17. I think we did that earlier in a previous problem, right? 14 divided by 17 equals 0.824. Remember, that was the difference between 82% and 82.4%. Yeah, I brought that out to 3 sig fig now, so it's 82.4, which is 82.4%. So I didn't really have to do this. What I needed was 125 grams of NH3, and I have 82.4% over here is 0.824. So when I multiply that together, times 125 equals 102.94. grams of N. And so this is going to be to 3 sig fig. So it's going to be 102.9, which is 103 grams. Oh my gosh, that was a long one for me because I did this without having to do that. We didn't need to do that part. We just needed 82.4% of 125, which is what happened down here. So that's why the answer is 103 grams for, when was that? 37A. Whew. I didn't check back to the other problem because I just assumed that we didn't have that information. So I was trying to figure out what that percentage was, but I took a wrong turn. And that's why I did this extra stuff that we didn't need. All right, so that is 10.11, 10.11 on page 329. Let's go to, we have 2 more types of problems. So now I'm on page 331. On page 331, we have determining the empirical formula of a compound. If you know the percentages, then you can figure out the formula of a compound. So let's see how. And here, a compound is analyzed and found to contain 20, what does that say? 25.9% nitrogen and 74.1% oxygen. What is the empirical formula of the compound? All right, so it's going to be an N and an O. So we have this compound, which is, I don't know, and oxygen, I don't know. So we're trying to figure out X and Y. And here's what I know. The percentage of nitrogen is 25.9%, and I know that oxygen is 74.1%. Okay. And actually, I was going to do this, but remember, we have this as a sample problem already. So what you're going to do is if you have 25.9 grams and you have 74.1 grams, and we're trying to figure out this empirical formula, then what you're going to do is you're going to take this and here's your percentage, but go ahead and take this percentage and call that. This is a trick often used in chemistry, and you're going to assume certain things. So you're going to assume 100 grams. Why? Because if you assume 100 grams, that's the trick. So I'm going to put stars around it. If you assume 100 grams, then you can now call this 25.9 grams, and you can call this 74.1 grams. Okay. So let's say there's 25.9 grams of nitrogen in 100 grams of this compound, right? And I have the weight, but if I have this weight, what I can do is I know what the atomic weight is of nitrogen. We've looked that up, and I know it's 14.007. So since this is 3, I'm going to leave this at 3. From the periodic table, the equivalence factor is 14.0 grams in 1 mole of nitrogen. So if I figure that out, then what do I get? I get 25.9 times 1 divided by 14 equals, okay. If I had 100 grams of this compound, then I would have 1.85 moles of nitrogen. Similarly for oxygen, just do it the same way. 74.1 grams of oxygen times 1 mole of oxygen weighs 16.0 grams. And if I calculate that out, then what I get is 74.1 divided by 16 equals 4.63 moles of oxygen. Okay, so that's good. So that again is the assumption. If I have one mole, if I have 100 grams of this compound, then this is what I would have. I would have 100 or 1.85 moles of nitrogen and 4.63 moles of oxygen. Well, now what I can do is I can take this, I have these two mole numbers. If I divide both of them by 1.85, let's see what I get. 14 or 4.63 divided by 1.85 equals 2.5. Ooh, I can work with that. Right. So if I take 1.85 moles and we divide, and I have 4.63 moles. If I divide both of these by the lower of the two numbers, and the lower of the two numbers is 1.85, I'm gonna get 1.85 and that equals 1. And then I got 1.85 and that equals 2.5. All right, so now what I know is that for every 1 mole of nitrogen, there's 2.5 moles of oxygen. Well, 2.5 is not a number I'm going to work with, so I don't want to say N1O 2.5. So I want to get this 2.5 to be a whole number. Well, then what I can do is multiply that times 2. But if I multiply this times 2, I'm going to multiply that times 2. So this becomes N2, that's 1 times 2. And then O 2.5 times 2 is 5. So my answer is N2O5. So that is what we're trying to get at right here, the empirical formula of a compound. Woo! So 2 tricks here. The trick is to assume 100 grams so you can get this stuff. And then the other trick here is divide by the lowest number, by the lowest of the 2. So to get through this problem, those are the 2 things you got to know. Righty. All right, let's do an actual problem. Let's do 39.A. All right, so 39A says calculate, same problem, calculate the empirical formula. And you've got 94.1% oxygen, you've got 5.9% hydrogen. All right, so if we do oxygen, what we're going to do is assume 100. So this makes it, this becomes 94.1 grams. And we multiply that by the conversion factor, equivalence factor, which is in 1 mole of oxygen, you have 16 grams. Similarly over here, 5.9 grams. You're going to multiply that times the mole, the atomic weight of hydrogen, which is going to be 1.01, just 1.0. Well, this says 3, this says 2. I'll just say 1.10 grams divided by 1 mole. And this is the hydrogen, and this is the oxygen. So when we work that out, what do we get? 94.1 divided by 16 equals 5.88 moles of oxygen. And then you got 5.9 divided by 1.01 equals, ooh, they're the same. They're 5.84 moles of hydrogen, so it's 1 to 1. I don't need to multiply. They're the same if I, you know, look at a 2 sig fig. This is 5.9, and this is, ooh, this is 5.8. But this will give us the same thing. So the answer is for oxygen and hydrogen, you're going to have 1 hydrogen. And if you have a 1, you don't say it. It's understood that there's one. And then you have oxygen, and there's one right there. So it's going to be 1-to-1 HO, or actually the way we write is OH. Like sodium hydroxide, which is what this is. This is hydroxide ion. Whew. So that is the hydroxide ion will be OH minus. When it's not the ion, then we write HO though. So really that's the answer. So because it's without the ones. So without the ones, it's HO. So box your answer. Your work is shown. That's 39A, and you can do the rest of them. And then the last one, last type of problem comes on page 333. Page 333, we have finding the molecular formula of a compound. Here's the question. Calculate the molecular formula of a compound whose molar mass is 60.0 grams per mole, and empirical formula is CH4N. Okay, so the molecular formula. Now the empirical formula doesn't exactly tell us, it's in this percentage, which means there's going to be whatever this, sometimes you write it like this. Let me see. This is sample 10.13 on page 333. Now the empirical number tells you that for every carbon, for every mole of carbon, for every atom of carbon, if you want to look at it that way, there's going to be 4 atoms of hydrogen. And for every atom of carbon, you're going to have 1 nitrogen. But you can take this whole thing and multiply that times 2. And although this is the empirical formula, it might not be the actual formula of the compound. Compound could be C2H8N2. It could be C3H, 3 times 4 is 12, and same as C3. So these are formulas, but the empirical formula tells us the ratios, but not necessarily the actual formula. If you were to take a look at a molecule of this compound, and count the number of hydrogens, it might not be 4, it might be 8, it might be 12. All right, so here's what we got to do to figure this one out. All right. So over here it says you're going to calculate the empirical formula mass. There's the empirical formula without the 2 there. So we take C, H4, and N. You have 1 C, and that's at 12. You have 4 H's, and that is 1.008. Let's just call it 1. So we can do this, eyeball this, and N is 14. We have 1 of those. So if you look at it, it's 12 plus 14, which is 26, plus 4 of these, which is 30. So 30 grams is what CH4N was. Well, here's what we have. We have 60 grams. Ooh. We have 60 grams. We don't have 30 grams. We have 60 grams. So actually then, to make this 60, it's pretty obvious that you just multiply this 30 times 2 to get 60. So we're going to multiply the empirical formula times 2 to get C2H8N2. So that is our actual answer. Let's make sure we got this right. Ooh, there it is. C2H8N2. Ta-da. All right. Let's do one. Oh gosh, there's only 2 of them, but let's do one. Let's do 41. 41, what is the molecular formula of a compound with an empirical formula? CCl, and so a recursive L, so you can see the difference between that. And there's one of each of those. And then the molar mass is 184.5 grams per mole. Now the empirical mass we can see is 12 plus 35.4 plus 14. You can look those up if you want, but carbon is 12.011, chlorine is 35.4, and nitrogen is 14.007, right? So when I add all that up, that's 8, 1, 4, 11, carry to 1, 2, 5, 6, 61.418. I can already see now that's going to be times 3. 61 times 3, 6 times 3 is 18. And this is over 1. Let's just multiply it. But you can see that you can do that in your head. And a lot of times in chemistry, you have to see if the thing makes sense. So does this make sense? Yeah, this is 3 times this. So it's going to be C3, Cl3, N3. But let's show you how to do that mathematically. That'd be 184.5 divided by 61.4 sig fig, 61.42. I round off at the end, so I'll give I'll put all of those in there. So you get clear 184.5 divided by 61.418 equals, look at that. It's like right on the dot 3. 3 sig fig, doesn't matter. 3 sig fig, you got it. And so our empirical formula is CCl, and but to get to 184.5, I'm going to multiply this formula times 3. So everything within here times 3, so C3, Cl3, and 3. That's my answer. I'm sticking to it. That's number 41. Woo! All right, and don't want to do any more because I don't want to spoil your fun. Because out of these two, I just did half of them. So you do that one, and going backwards, it's the same way. Like there's only one problem to do here on the sample problem 10.2. So you do 40, and we already did 39. So you do 39B, like we did 39A. Yes, we did. It's 39A right there. So now you have enough knowledge to do all of those guys. All right, so I'm gonna stop share and ask you how many questions. Ooh, oh, something else. All right, so you have on this problem set,